Hi everyone, and welcome to this new video on highest common factors and lowest common multiples. So, the GCSE, they used to ask you really straightforward questions. Like they used to give you two numbers and just simply find the highest common factor, blah 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 blah. And you would write them as prime factors, bung them in your Venn diagrams. It was the easiest question in the world. As of say 5, maybe 6 years ago, it's 2020 now if you're watching this in a different year, the exam board decided to change the questions to make you think, and I'm all for that. They're much better. Some of them, wow, they're hard, and I've really tried to find them on the internet. I can't find them, and so I've tried to make up some of my own, but when you start doing past papers you'll find loads of them. So let's have a look at this problem. So we know the highest common factor of 84 and a missing number is 42, so you can see it's like a reverse engineered problem of what we used to have. And we also know the lowest common multiple, but we've got to find out that missing number. Now to do this, I'm going to draw a Venn diagram, because as soon as I see highest common factors, lowest common multiples, I am drawing a Venn diagram. So we know this one's 84, and we know this is x. Now I'm just going to draw another one actually, and I'd never normally do this, I just want to make a point, because people do a lot more working for these than they need to. Now, because we know the highest common factor is 42, I'm going to put the 42 in there, because that is what the highest common factor would be. That's where it would go. Now, you might be really upset now, be like, oh, that's not prime numbers. So that's why I drew a second one. So for example, I'll just tell you 42 is 2 times 3 times 7. So if I wanted prime numbers, like product of primes, that is what it would look like. What has to go in here? Well, that has to be a 2, doesn't it? 42 times 2 is 84. Now, the other bit of information we know is everything multiplied in here is 756. So what I've got to find out is what's going in there. So what is 756 divided by 84? 9. So all three of these numbers multiply together to make 756, and if you're really obsessed with the primes, it should look like that. Okay? Why go for that? And this is so much easier. This will solve the problem you need it to, but if you want to go for the one I've just crossed out, that's up to you. You're just making work for yourself. So I've got a highest common factor of 42. That has to be a 2 to make 84, because 42 times 2 is 84. We know that number. We don't know this one, but we don't know this one here, sorry, but we know all three of these sections multiplied together is 756, so I just worked it out. Okay, so now all we've got to do is work out this problem here. So what is 9 times 42? It is 378. And again, I could have multiplied everything in there. It's just quicker to do 42 times 9 rather than all of that. I've got another one for you. I think I meant to do this one first because the numbers are nicer. So if you've understood that one, this is going to be easy. So if you have understood it, pause it, have a go, and then hopefully you get that warm fuzzy feeling when you see the same answers as I have. So I'm only going to draw one this time. Highest common factor of 60, so one of them is 60, and the other one we don't know, so we'll call that x. But we know the highest common factor is 12, so we bung it in the middle. What do we have to multiply 12 by to get to 60? That has to be a 5. Now, the lowest common multiple is 420. So these three sections here, 1, 2, 3, multiplied together is 420. So we have a 60 here. Well, this must be a 7, mustn't it? This is much easier. No calculator needed for this one. So 60 times 7 is 420. So what is this missing number here? 12 times 7 is 84. If you really wanted to do the prime decomposition, it would just look like that. It's not a difficult one. Okay, so I'm going to give you a few of those to practice, but there's other types. So check this one out. Now this is my personal favourite. I love it when I see these. Most people get these horrendously wrong. You'd be amazed what rubbish people write for these. Makes me laugh, so that's always good. Okay, write as a product of primes, but we're given x and we're y, so we can't normally write 9x as a product of primes because it's an x, right? But we know x is this big number here. So many people are obsessed with actually working this out. They type it all in their calculator, times by 9, just write a massive number. It's not what it says. It says write it as a product of primes. So we know x is written as a product of primes, but we want 9x's. So we're actually going to times that by 9. 9's not prime. So, but 9 is equal to 3 squared. So if we're timesing this by 3 squared, are there any other 3's to join it onto? No. So we're just going to write it all out exactly the same. But you can see I've left a gap there, because that's what we have at the moment, but we're timesing it by 9, so we need a 3 squared in there. Simple as that. 12y is a little bit more confusing, because 12 is 2 times 2 times 3 as primes, or 2 squared times 3. So we have to multiply y by 2 squared times 3. Well, we already have a 2, but if we're multiplying it by another 2 and then another 2, we're going to have 2 cubed. We already have a 3 times 3, but we're timesing it by another 3, so we're going to have 3 cubed, but the 5 and the 13 isn't changing. We don't ever have to work out these numbers, and it's hopefully you're looking at that going, oh, it's easy, but you'd be amazed what people write. Now, let's put this one in. So, this one's definitely harder. X times y, and then times by 2. So let's leave the times by 2 to the end. Maybe let's just work out what xy is. Okay, so let's times these together. So we've got 2 cubed times 2. So that's 2 times 2 times 2 times 2. And that's 2 to the power of 4. Do you know what? I can do this at the same time. So, and another 2. So it's 2 to the power of 5. So here we've got 1, 2, 3, 4, and we're also timesing it by 2 again, so 5. So we don't have any other numbers here to worry about. So let's just have a look. So x times y, there's no 3's in x, so nothing to times that one by. We've got 5 to the power of 4 times by another 5, so we've got 5 to the power of 5. No more 7's, no more 11 squareds to worry about, and no more 13's. So basically you just multiply these together and then also multiply it by 2. There we go. Okay, 3x squared. You can pause it if you want to, have a go at this and then hit play. So we've got to do x times x. So that is everything in here times by itself. So it means 2 times 2 times 2 is also going to be times by 2 times 2 times 2. So now we have 2 to the power of 6. We've got 5 to the power of 4 times another 5 to the power of 4. We can add the powers if you're using indices to do this as well. So base stays the same, add the powers. But I've missed one, so I'm just going to rub that out, because I've also got to times this by 3, but there's no 3's in x's, so there it goes in there. 7 is going to be times by itself, so we now have 7 squared, and 11 squared is going to be times by itself, so it's 11 times 11 times 11 times 11, that's times 11 4 times. There we go. Love those questions. I'm going to give you some of those to practice. Now, this is potentially the easiest one. People do it on all sorts of strange methods, but let me just explain this question. So we've got 3 lamps. Who come up with this, I don't know. But 3 lamps that they flash at different intervals. Why? Don't know. But lamp A flashes every 20 seconds, lamp B flashes every 45 seconds, and lamp C flashes every 120 seconds. So let's imagine we switch them all on at exactly the same time and they go flash. And then obviously lamp A is going to flash before lamp B, and then lamp B is going to flash before lamp C. But there will be a time when they all flash at the same time. So before they might have asked you this question and said, when will that happen, after how long? But now they're going a little bit further. How many times will they flash at the same time in 1 hour? Okay? So if you think about this, it's like lamp A is every 20 seconds. So you could just write out all the multiples of 20, all the multiples of 45, all the multiples of 120, and try and find out the lowest common multiple. Okay, that would tell you when that all happens. I'm just not a fan of that. So 20 is 2 squared times 5, 4 times 5. This is 9 times 5, so that's 3 squared times 5. This one's a bit harder, so this is 12 times 10, and 12 is 2 to the power, sorry, I'm just going to do that. That's, trust me, it's 120. I'll tell you what, actually, I didn't tell you this before because I don't like telling people this, but it's a little secret for you. Type in 120 in your calculator and press equals. Now, if you have a Casio, you have it. If you don't have a Casio, I have no idea what you have. So buy a Casio. Now, on mine, I've got like an apostrophe, a little circle, and then like speech marks. And above that, it says fact. If you press shift and then fact, it will tell you the prime factors. Pretty neat. I've never used it before until now, but I just knew the calculator did it. So I could draw a three-way then. A, B, C. Now, what is common to all of them? Well, we can see there's a 5. That's it. So let's go to A's and B's. So let's compare these. Nothing common, so nothing's going in there. Let's do B's and C's. They have a 3. That's it. Let's do A's and C's. They have 2 squared in there. So what else has A got? Nothing. B, there's another 3 there. And C, there's another 2. So I can find the lowest common multiple. We're writing all the multiples. That can take some time just by multiplying all these together. So let's do that. 9 times 5 is 45, 90, 180, 360. So this happens every 360 seconds. I'm just going to write every up there. Well, we're talking about hours, so seconds is really not that helpful. So let's talk about minutes now. So we know there's 60 seconds in a minute. So if we divide this by 60, that's every 6 minutes. So if it's happening every 6 minutes, that means it's happening 10 times in 1 hour. Because there's 60 minutes in an hour. Okay, so they're the sort of variations of questions you need to get used to. So I'm going to create a worksheet on them, and best of luck.